Loops are used to perform tasks repeatedly in a program. In tutorial 6, you will learn about one type of loop that is known as a while loop. We are going to discuss the flowchart of a while loop and also write programs that use while loops. Suppose that we are editing a file containing grades of students and would like to write a program to increment the grades of all students by 1 point. One way to do this would be to write a separate statement that performs the increment operation for each student. For example, increment student 1's grade, increment student 2's grade, increment student 3's grade, and so on. This can get tedious if there are a large number of students in the class because we would write a separate statement to increment the grade for each student. An easier way to do this is to use a loop. Here is the pseudocode. While not all student grades have been incremented, increment student i's grade. Here I is a loop variable. You need to initialize this to some starting value, say 1, and then increment it inside this loop. So the single statement, increment student i's grade, will be executed repeatedly and the variable I will be replaced by 1, 2, 3, and so on. When the value of I is 1, this statement would be increment student 1's grade. When I becomes 2, the statement would be changed to increment student 2's grade, and so on. When we use a loop, we don't need to write separate statements to increment each student's grade. Instead, we can use a single statement that contains the loop variable I. This process of performing a task repeatedly can be done using a loop. There are two types of loops, while and for. We will discuss the while loop first, and you will also see the differences between the two when we discuss the for loop. A simple flowchart for a loop is described here. First, the condition is checked. If the condition is true, then some task is performed. This is repeated until the condition becomes false. When the condition becomes false, the loop is exited. In a flowchart, conditions are checked within decision boxes that are diamond-shaped. If the condition is true, then an arrow leads to a rectangular box that describes the task that must be performed. After this task has been performed, another arrow leads back to the same decision box that checks whether the condition is true. If the condition is false, then a different path is taken, one that leads to the first statement outside the loop, and the loop is exited. A while loop repeats a statement or a group of statements while a given condition is true. It tests the condition before the execution of the code within the loop starts. The code within the loop is called the body of the loop or the loop body, and this must be indented by a few spaces, typically 4 spaces. The following program shows you a while loop. I equals 0, new line, while I is less than 3, colon, new line, 4 spaces, I equals I plus 1. In this program, first, the variable I is initialized to 0. Then the loop condition I is less than 3 is checked. Because this condition is true, the loop is entered and the statement within the loop I is equal to I plus 1 is executed. This will change the value of I to 1 from 0. Then the loop condition I is less than 3 is checked again. As this condition is true, the loop is entered and I is incremented to 2. The loop condition I is less than 3 is checked again. Once again this condition is true, so the loop is entered and I is incremented to 3. Now when the loop condition is checked, it will be false, so the loop will be exited. When you're writing while loops, remember that you need to follow rules for indentation, punctuation, and spelling. Otherwise, there will be syntax errors. Let's take some examples to help you understand how to correct syntax errors. For example, here we have a program with an error. When you run this program, Loquacious will give a parse error. So what is the problem here? Look at the second line. Remember that a while clause must be terminated with a colon, but there is no colon here. So that is going to lead to a syntax error. You can correct the program by adding the colon as shown in this program here. So the while clause, which was previously written as while I is less than 3, has now been corrected to while I is less than 3 colon. Let's look at this next example. J equals 20, new line, while J is greater than 10, colon, new line, J equals J minus 1, new line, print J. The keyword while is written in uppercase letters. So when you run the program, Loquacious will again give a parse error. The reason is that keywords are case sensitive. So you must write the keyword while in lowercase letters. You cannot use uppercase letters. What is the other error here? The statements inside the while loop have not been indented. For example, in this program, we would like to print out the value of j, as well as decrement the value of j for every iteration of the loop. These statements have not been indented, so they are not in the loop body. To correct this problem, you would need to add 4 spaces before each statement. You can see the corrected program here. J equals 20, new line, while j greater than 10, colon, new line, 4 spaces, j equals j minus 1, new line, 4 spaces, print j. So when you write your programs, check the indentation, punctuation, and spelling if Loquacious gives a parse error. Next, we look at logical errors that can arise in your program when while loops are used incorrectly. With a logical error, the program will run, but the program output will be incorrect. So let's look at this program here. I equals 0, new line, while I is less than 3, colon, new line, 4 spaces, print I. What is wrong in this program here? The syntax appears to be correct. There is a colon at the end of the while clause. The loop body is indented correctly. If you run the program, Loquacious does not give any syntax errors. However, the problem is that the program will continue to run indefinitely. That is, there is an infinite loop in this program. What is the reason for this loop? If you examine the loop body, you will see that we are printing out the value of the loop variable I. So to begin with, I is initialized to 0. Then in the while clause, we are checking if I is less than 3. And if it is, then we are printing out I. Note that we are not modifying the loop variable in any way inside the loop body. So as a result, the loop condition will always be true because I always has the value 0 and the loop condition is 0 less than 3. So this while loop is an infinite loop. It will continue to run forever. What you can do is refresh the browser in which you're running this program, and that will terminate the program. However, you have to take care to avoid creating infinite loops in your programs. So you must modify the loop variable in your program. For example, here you can see the corrected program. Within the loop body, we are modifying the loop variable. Let's read this again. I equals 0, new line, while I less than 3, colon, new line, 4 spaces, I equals I plus 1, new line, 4 spaces, print I. So we have added a statement here which is incrementing the value of I inside the loop. Every time the loop executes, I will be incremented by 1. So to begin with, I is 0. After the first loop iteration, I becomes 1 and the condition that is checked is 1 less than 3. This is still true, so I will be incremented again. I becomes 2 and then the condition 2 less than 3 is checked in the while statement. This is again true, so the loop body is executed again and I is incremented to 3. Now the loop condition 3 less than 3 is false and the loop will be exited. So this is a very important point to remember when you're writing loops. make sure that you are modifying the loop variable so at some point of time the loop condition will become false and the loop will terminate. Let's take another program. J equals 20, new line, while j greater than 10, colon, new line, 4 spaces, j equals j plus 1, new line, 4 spaces, print j. What is the error in this program? There is no syntax error here. If you run this program, you will find that there is no output that is printed and the program will run indefinitely. So there is an infinite loop in this program. Now we are modifying the loop variable here within the program. The statement to modify it is j equals j plus 1. So we are modifying the loop variable. Then why does the program run indefinitely? Let's examine the values of the loop variable j and the loop condition more closely. To begin with, the loop variable j has the value 20. In the while clause, we are checking the condition j greater than 10. So initially 20 is greater than 10, so it is true. Then in the loop body, we are incrementing j by 1, so j will become 21. This condition j greater than 10 will always be true because we are incrementing j. So j starts at 20 and when we increment j, it will take all values greater than 20. So the condition j greater than 10 is always true, and that is why we have an infinite loop here. There are many ways to correct this problem. One way to correct it is to decrement the value of j instead of incrementing it. So in the loop body, instead of writing j equals j plus 1, we can write j equals j minus 1. And when we decrement the value of j, then at some point of time, the value of j will become less than 10 and the loop condition j greater than 10 will become false, and so the loop will be terminated. Let's take an example of a while loop. Consider the following problem that we will solve using a while loop. Write a program to display numbers starting from 1. When a number is a multiple of 5, display the word multiple instead of that number. Terminate the program when the word multiple has been displayed 3 times. When you're presented with a problem, you can do one of two things. You can draw a flowchart to solve the problem, or you can jot down the sequence of steps to find the solution using an informal language called pseudocode. Pseudocode is a description of a program and it does not have syntax rules. As you gain experience programming, you will be able to write the program directly without needing to use a flowchart or writing pseudocode first. For this problem, we will use a flowchart to help us find the solution. Note that we want to display numbers that start from 1. We look for the terminating condition first. This problem tells us that we should terminate the program when the word multiple has been displayed 3 times. So we need a variable to keep count of the number of times the word multiple has been displayed. Let's call this variable count. We also want to keep a variable that keeps track of the numbers that are being displayed. Let's call this variable num. We will initialize num to 1 because the problem says that we want to display numbers starting from 1. So here you can see that our first operations box in the flowchart has 2 initialization statements. Num is set equal to 1 and count is set equal to 0. Next, we look at the terminating condition. The word multiple should have been displayed 3 times. If count is equal to 3, it means that the word multiple has been displayed 3 times. Otherwise, if the count is less than 3, it means that it has not yet been displayed 3 times, so we want to continue displaying the numbers or displaying the word multiple. If the condition is false, then the program will be terminated. Otherwise, if the condition is true, we want to check if the number is a multiple of 5. We can do that using the modulo operator. So if num modulo 5 is equal to 0, then we will display the word multiple. So if this condition is true, then this leads to a operations box that prints out the word multiple, and it increments count, because variable count keeps track of how many times the word multiple has been displayed. So we have two statements here, print double quotes multiple double quotes, and the second statement is count equals count plus 1. So note that you don't need to write valid Python code in a flowchart. You could simply write increment count and print multiple, anything that makes it easier for you to understand what operations have to be done at this point in the program. If the number num is a multiple of 5, you will print out multiple. But remember that this is a decision box. What if the number is not a multiple of 5? Then the condition will be false, and in that case we will print out the number directly. So the operation that is executed is print num. After this, we will have to increment the number num. So we will then check the next number. You can see that these operations then lead to the next operation, which is num equals num plus 1. So we are incrementing the number. And then we are going to go back and check the condition whether count is equal to 3. This operations box takes us back to the decision box count less than 3. And if count is not less than 3, then the whole process will be repeated again. So you can see that there is a loop here that is going to be executed, in which we check whether count is less than 3, then we check whether num modulo 5 equals 0, and then perform one of the two operations, either print multiple and increment count, or print the number num. Once count becomes equal to 3, the program will be terminated. Now once you have this flowchart, or you have written some pseudocode that describes the sequence of steps in your program, you can convert it into Python code. Next, we will use the flowchart that we have created to write our program. To begin with, we are initializing the variables num and count. Recall that num is the value of the number that is to be displayed. So we are going to be generating numbers starting from 1, and num has been initialized to 1. The variable count holds a count of the number of times the word multiple has been printed out. To begin with, this is 0. So count is initialized to 0. We are going to start off by creating these variables. Num is equal to 1, new line. Count is equal to 0, new line. The next step in the program is to check the value of count. If it is 3, then the program is terminated. Otherwise, these statements will be executed, the statements that follow this condition. And as you can see, there is a loop here. So we're going to create a loop that checks this condition repeatedly. While count less than 3, colon. We will create a conditional statement, and because this statement has to be executed as part of the loop body, we must indent it. Here we will use an indentation of 4 spaces. And we write our conditional statement here, if num modulo 5 equals 0, colon. Now what is to be done next? If this condition is true, then we want to execute these operations where we print out the word multiple and we increment the value of count. So note that they are part of this conditional block, and that is why we must indent these statements by 4 spaces from the start of this conditional block. That is from here. We must indent them by 4 spaces. If this value of num is a multiple of 5, then we will print out multiple, and we will also increment count because multiple has been printed out once. Now if you don't indent it like this, it would create a syntax error, because here there are no actions to be performed if the condition is true. So indent these by 4 spaces. What happens if the condition is false? If this condition is false, then it's printing out the value of num. So we will write an else clause, and this else clause must line up with the if clause. So we give 4 spaces, else colon, and in the body of this else clause, we are going to print num. So if num is not a multiple of 5, we print out that number. Now there's one other thing that's left, and that is to change the value of num, because we are starting with the value of num, which is 1. We want to change it to 2, 3, 4, and so on. We must keep on incrementing num. And note that this operation is not part of the conditional statement, which checks whether num modulo 5 is equal to 0. But it is part of the loop body, so we indent it by 4 spaces. 4 spaces, num equals num plus 1. Now let's run this program.
The program output is 1, new line, 2, new line, 3, new line, 4, new line, multiple, new line, 6, new line, 7, new line, 8, new line, 9, new line, multiple, new line, 11, new line, 12, new line, 13, new line, 14, new line, multiple, new line.
As you can see here, the word multiple is printed out whenever the number is a multiple of 5, and the program terminates after multiple has been printed out 3 times. Now what if we make some errors in our program? For example, let's say that I did not indent this operation num equals num plus 1 by 4 spaces. Do you see what the error would be? Now in the while loop, the variable num is not being changed at all. So what happens? If num is not changed at all, then it will always stay at the value 1. So 1 modulo 5 equals 0 will always be false, and count will never get incremented. We would have an infinite loop. So if we don't indent here, it is lying outside the while loop. Any statements that we put here that are not indented will be executed when the loop is terminated. That is, when this condition becomes false, only then these statements will be executed, because they lie outside the loop. Now, because we want num to be incremented while the loop is executing, we must indent it by 4 spaces. When you start writing programs, it's very important to use print statements to debug values. And this is especially true if you're working with loops such as while and for loops. These are some of the trickier concepts to master. And the best way to learn how to use these loops in your programs is to write lots of programs that contain loops and debug them by printing out the values of variables in your program. If at some point you observe that the program does not print out anything but seems and the browser seems to be hung, then you can refresh it by clicking on this, and that will refresh this page, so you can start writing your program again.
Let's examine the flowchart for a program to display even numbers between 0 and 5 and use it to write our program. We create a variable called I to store numbers in our program. At the start, we assign an initial value of 0 to I. Then we check if the variable I is less than 5. If it is not less than 5, terminate the program. This can be done using the while clause, while I is less than 5, colon. The loop body is executed while the condition I is less than 5 is true. In the loop body, check if the number is even. You can do this by dividing number by 2 and checking that the remainder is 0. I modulo 2 gives a result of 0 if the number is even and a result of 1 if the number is odd. We can create a conditional statement for this as follows. If I modulo 2 is equal to 0 colon. Now we want to display the number if it is even. So in the body of the if condition, we add a statement to display I, print I. Then we need to increment the number to generate the next number and repeat the process. The value stored in I is incremented using I is equal to I plus 1. If you forget to increment I, an infinite loop will be created and the program will never end. The reason for this is that the value of I does not change in the loop body, and so the condition I less than 5 will always be true. To terminate this program, refresh the browser like this. Also, note that you should not indent the statement like this. Why? I is equal to I plus 1. If you indent it, I will be incremented only when the if condition is true. That is, I modulo 2 is equal to 0. Then, if the condition is false, I will not be incremented and we will have an infinite loop. Now let's see question 6-5. This question uses input concept that we learned in previous tutorials. Prompt a user to enter a name and read it into a variable called new name. Using a while loop, we repeat this process until the user enters the name Merseith. Now, to get the input from user, we'll use inbuilt input function. We are asked to store this value in the variable new underscore name. Hence, we are going to write down new underscore name is equal to input open parenthesis single quote, please enter the name Merseith. Single quote completed, close parenthesis. Now we have to prompt user to enter the name again until the name Merseith is entered. So we will have a while loop with condition check. So now I'm writing while new name is not equal to double quotes Merseith double quotes. So basically in my while loop, I'm supposed to check if the number name is Merseith. If it's not, I'm supposed to ask user to enter the name again. So in my while loop, I have written down the condition new name is not equal to Merseith. If it's not, then I'm going to write down new name is equal to input open parenthesis single quote, please re-enter name single quotes completed parenthesis closed. And now let's run the code. Let's see question 6-7. Using a while loop, write a program that takes the elevator to all the floors from 0th floor to the -5th floor. The method go underscore to underscore floor in the class glass elevator takes the floor number of the destination floor as argument and moves the elevator to this floor. When the elevator reaches the -5th floor, display the following text: the elevator has reached the destination floor. In this problem, we need to write a program that takes the elevator to all floors from 0 to the -5th floor. One way to solve this is by calling the go underscore to underscore floor method repeatedly with the different arguments 0, -1, -2, etc. Elevator dot go underscore to underscore floor open parenthesis 0 close parenthesis. Elevator dot go underscore to underscore floor open parenthesis -1 close parenthesis. Elevator dot go underscore to underscore floor open parenthesis -2 close parenthesis, and so on. It's easier to use a loop for tasks that have to be performed repeatedly. We will create a variable called current underscore floor that stores the destination floor number to which the elevator is to be moved. This condition checks whether the current underscore floor variable is not equal to -5. current underscore floor, we create a while clause that checks this condition and executes the loop body while the destination floor is not equal to -5. While current underscore floor is not equal to -5 colon. So all the statements in the loop body will be executed repeatedly until this condition becomes false. In the loop body, we will decrement the destination floor number that is stored in current underscore floor by 1 and move the elevator to his floor. Current underscore floor is equal to current underscore floor minus 1. Elevator dot go underscore to underscore floor open parenthesis current underscore flow close parenthesis. Now, in each loop iteration, the variable current underscore floor is decremented by 1. This value is given as an argument to the go underscore to underscore floor method. To move the elevator to that floor when current underscore floor becomes -5, the elevator has reached its final destination and the loop will be terminated. We will then display the statement the elevator has reached the destination floor. Print single quote the elevator has reached the destination floor single quote.